And as we know, and I already tell you, uh, the biostatistic, actually, a statistic is a sign of collecting data, arranging data, and analyze, right? Now, when we collect, already collect the data, now we start to analyze our data. Okay, now, today I will talk to you about how to analyze our data. Usually, we are comparing our data some condition, right? For example, we have the two uh, data from a different population. Yeah, for one A population and the B population. Okay, and these two data is come from a normal distribution computation. If you ever learn about the statistics, I think your teacher should tell you, if you want to compare two mean of the population, there will be have five conditions. Yeah, I will tell you how. Let me review your statistics. Review your statistics at when you are undergraduate university. When we want to compare two mean of two work from two population, usually we have five methods. That means we will have a five condition. Different condition we use different method. First, when the variance of these two of the two population is known, these two population is known, we usually use the tester D, right? And the D formula always written like this. Use the first mean of the first population minus the second, then divide by the root square of like this. We use this D, we calculate, we usually estimate D from the data. Then we compare with the theoretical normal distribution of the D table, or we call that normal table, right? We compare with the D, okay? And according to the alpha we choose. For example, alpha we choose for 0.05, okay? And the D will be, here will be 95%, and here will be 5%. So D will be 1.6445. Okay, because here this area is 0.45, so the criteria of the D is 1.645. That means, what do you mean? That means the estimated D, if here, I mean your hypothesis. Before we're doing any analysis, we have to establish a hypothesis. Okay. I mean, before you use our data to doing any statistic analysis, we have to establish a hypothesis first. Usually, hypotheses include two types of hypothesis. First is we call that is the null hypothesis. Second is we usually call that anti-hypothesis. In your mind, I hope you keep in mind, null hypothesis usually mean equal. Before and after is equal. Any change is no change, nothing. Okay? So here should be equal or no change. Anti-hypothesis should will be not equal change. Okay? So no change and change, that means different and different. Okay? So if we want to compare two mean of two populations, usually we have twice answer. First situation is two variance from the two population is known. We can use the tester. We call that estimated Z to compare with the theoretical Z. Theoretical Z, if our alpha we choose 0.05, then the Z, the criteria Z will be 1.645. Okay? And if your Z, after you calculate that, the D is larger than the criteria Z here. That means H1. We accept the H1. We accept this hypothesis, okay? But if your Z is lower than the criteria Z, for example, your Z is 4, located at here, that means the hypothesis we accept is null hypothesis, okay? Yeah, so that is me before equal after, or we can say mu1 equal to mu2, but here is mu1 not equal to mu2, okay? Sometimes you will ask me, what is two-way, what's one way, right? Two-way or one way, what does it mean? It depends on the hypothesis hypothesis you define. If you just want to know this two mean is equal or not equal, equal or not equal, here is two-way, because here is not equal, but here also not equal. You understand? For example, my weight, your weight, you and me, our weight is quite different. What is quite different? Just different, right? But is you are larger than me, or mine is larger than you? We don't know. So maybe here, maybe here. So there is a different, a two place may make the lunar anti-hypothesis will be accepted. So if we just want to know the two mean is different or not, we will choose two-way method. So if we use the two-way method and our alpha is 0.05, here D will be how much? D will we choose? We will use alpha divided by 2. So the D will, this criteria D will be 1.96. Why? Because here is 95, right? 95, we divided two parts. So this part will be this part will be 0.475. Right? So you check in about the normal table, the table. Here will be 1.63. This is a two-way. But if you want to know for example, I want to know my, for example, I invented something. I want to my medicine, the efficiency will larger than before. So my hypothesis, maybe I can make like this. This is after, okay? For example, your English score before my training is very low, but after my training, maybe you will rise up your English score. I will prove this, so I will make a hypothesis, right? And I hope your score will larger than before, right? So this is I will larger than you. So only one way. Only one side, one way. Only one choose. I am larger than you, or either I'm larger than you, or I'm lower or equal. So only one way, or only one choose I can select. So this is one way. Somebody say one here, or not one way, okay? And here is one way. If also your alpha is, your criteria alpha is 0.05, the critical D will be alpha, and it will be 1.4645 because here is 95%, but here is only 45%. It's 0.45. So here the critical D will be 1.645, right? This is what we say about one way. This is what we say two way. If there have two conditions will happen, we usually call this two way. If only I just only one condition, I just only one condition happened. This is one way, okay? And the alpha we use is alpha, but this condition we choose is alpha by 2, okay? D is what? Here. Yeah. So here it's H0. Here will be H1. Exactly here, what? H0. Okay? If your estimated D is exactly equal to 1.645 here, it's still 0, H0, okay? Yeah. Even here, and here, H0, H0. Only here is H1. Okay, null hypothesis and the anti-hypothesis, okay? We have to make our concept clearly, okay? And it's actually I am making a review of your statistics from when you are undergraduate university. First, when two variance is known, we can use this test to compare with the theoretical Z. And okay. And if our estimated D is larger than theoretical, that means H first be accepted. We accepted the first anti-hypothesis. On the other hand, yeah, it's still worse. Null hypothesis is accepted. Okay. Okay. This is the first condition. There will be 5 conditions. First is that. Second is when the variance of two populations is unknown, just like this. But the sample size N1, first population, the sample from the first population plus the sample size from the second population is larger, at least is larger than 30. Then then the test we use is also D, but the formula we use is we change the variance from population to sample, small s. Okay, and also compare with the theoretical D. Okay, and to follow the rule, If the estimated D is larger than theoretical H1 accepted, estimated D is lower and equal to our theoretical H1, H0 will be accepted. There will be, what? Okay. Mm. Yeah. Oh, I understand your meaning. Two way, right? Your D estimated D should be larger than positive D, okay? Should be larger. If the D is a negative, should be lower. Here, here, or here, or, you know, only one, only one chance, okay? If you D estimated the D is positive, okay? Positive, I mean, okay? So it should be larger than this criteria. This it should be larger than the positive D. But if this D is negative, okay, for example, for negative 4, okay, because our criteria is, for example, right? So it's lower than this. Lower than this is H1 anti hypothesis is accept, be accepted. I understand. Okay. All right. Yeah. There is no relationship. Okay. Just but sometimes you will ask me because our sample is coming from sampling, right? The mean which got the data we can estimate is only from here, right? But why we know the variance of the population? As we know, the variance as we know the formula of the variance is calculated from any data minus mu, right? And the sum together, then divide by the all the number of the data, right? But we don't we don't know about this. But how we can know about it? We don't know about this. But this variance is calculated by this formula. So you will think confused. Now you will confused. Two variance from the two populations is known. Known. But we don't know if we know about the mu, we should know about the mean. We should have using the formula we have to use is the mean from the population minus, not use the mean from the sample. You understand? Who can explain this? Who can explain this? Do you know what I mean? Yeah, this formula is used. We use the samples. The mean is we come from sample. But the condition is when the variance of two populations were known. Oh my God! But the variance is calculated by this formula. Is any data minus mean of the population, and sum together divided by it. Huh? Can you tell me? Yeah. So you calculate this, he tell you the variance of the population unknown. But we don't know about the, the mean of the population. I will explain later, okay? Because this is not the point. I will tell you the five method, and I will explain later. But I'll let you thinking about it, okay? First, when you are, I just tell you, when you are undergrad university, when you're learning about statistics, the teacher will tell you five conditions. First, the variance of the two populations. No, the criteria these are like this, and the two populations are known, and the sample size is larger than 30, and then you can use this formula to compare with the theoretical, right? The third, these two variance is unknown, and the N1 sample size from two sample is lower than 30, but oh my God, again, variance is, if the two variance is equal, two variance is equal. I don't know about the mean, but how you can tell me they're equal? You understand? The teacher told me the variance is calculated from here. I don't know about this. How can I calculate this? And how can I know this is why? Okay, I'll explain later, okay? The third condition is two variance are known. Sample size is lower than 30, and the two variance is equal. The estimator, we don't use D, we use the T, and the T formula is like this. When you are undergrad university, you are crane, you know, the formula every day is very hard to crane. And the SP is combined as variance. It will be and the degree of freedom. Okay? Here. But today you don't need to crane. You don't need to remember this because right now you are already master student. Okay, you don't need to claim this. You just have to know why they were separate. 5 method, 5 condition. Because today we will use the software SPSS, so you don't need to remember or no need to claim about this formula. I just explain 5 conditions. First is this one, the second is this one, the third is this one. Different conditions use different formula. Okay? But right now you are already master student. Every day you have a very a large of data you have to analyze. You cannot estimate one data one by one formula. So this is why we are open a class for the SPS software to teach how to use the SPS to estimate all the data. Okay. But before we use the SPSS, I have to also review the concept of the comparing of the two mean from two population. When we are comparing the two mean from two population, we have to find condition. I just tell you 1, 2, 3, and the 4 is this one. Okay. When the variance also unknown, and the sample size is lower than 30, and the variance from the population is unequal, so the T will be another T. T will be the but the degree of freedom, it seems very normal. The degree of freedom is should follow this formula. Okay, you should use this formula to calculate the degree of freedom. Then you can check out the degree of freedom and the alpha D we compare with the theoretical T. Okay. What? Today I will tell you, when you are undergraduate university student, the teacher will teach you. When you compare the two main two populations, you have to find answer. But here, from here, I will tell you, only three conditions. And the test you use is T test. Only 3 conditions. First is one sample T test. Second is independent sample T test, and the third is dependent sample. Only, I mean, if you want to compare two mean from the two population, only 3 conditions. 1, 2, 3. It's different than this. You are confused. Why they have 5 and this only 3 methods? It's actually it's same. It is same. Ah, okay. If even you don't know your data, is coming from normal or not normal, right? You have to check out your data is normal or not normal, right? Sometimes our data, we always usually know our data is coming from normal. But sometimes even you don't know about your data is whether it comes from normal or abnormal. I will teach you. We use the SPSS to check out it. Okay, I will tell you the data. But here, what is normal? What is abnormal? I give a simple example. Okay, for example, we have the data of the primary school students' length, the height, okay, and this is the student's height, okay, from the primary school student, primary school student, and okay, this is the number of students. For example, 141, 142, 143, 144 centimeter. Okay, this is student number. Understand? Okay, and this is they are the third year student, and the fourth year just like this. They will grow up, right? The student will grow up. Then, so they will move, maybe like this. Okay, maybe they will grow up maybe from, okay. This is also number, this is the head of student, right? The fourth degree of student, a primary school student height. Because their growth continuously, right? Continuously, right? And also their data also concentrate, and located at some names, located somewhere. This kind of data, what we call normal distribution data. Okay, no more. Because the data happen normally. Understand? When the student from the third year up to the fourth year's degree, they will grow up, right? So the head of the student will normally grows up, right? So this is what we call normal. But sometimes, for example, we make a questionnaire, you understand? Questionnaire. Oh, questionnaire. I also want to ask some of you, your master C, who are doing about the questionnaire. Questionnaire, you know, understand? Yeah. For example, you will do questionnaire. You will do questionnaire. I will have the 1 or 2 week focus on questionnaire because there is not some processes you have to make. Okay. For example, you have to make questionnaire. What we use a lot of items of the question to ask the people, to test the people thinking, and we use all this data to analyze some study. research. But all the data from the people they choose is not normal and normal. Understand? Every question we call this item. Okay, one item, two item, one questionnaire at least. I suggest at least about 30 items. Okay, you should have 30 items. Okay, and the question you have. We always go out to ask someone on the street, right? And ask them to help you to choose to help you to answer the question, right? And you usually use five direction. One is disagree very much, right? Disagree very much, right? And disagree, and no comment, and agree, and agreed very much, right? For example, Professor Liu is the best handsome boy in NKUST. Oh, okay. Now you under my class, you always choose agree very much, right? Yeah, I know you. Because you want to get the high scores, right? But after you graduate, you disagree. Why he is so handsome? I am the handsome. I'm the best handsome. Right? Okay. This answer is we also use this data as a data. For example, he choose here. We give this location a number 1. If you choose the second place, we give you number 2. Right? Understand? So you usually have the 5 choose, right? So this is what we call Likert list. Likert is a social scientist. Okay, it defines this. But this 1, 2, 2, 5, this 5 number is not a nautical number. They are nominal scale. Nominal scale number. This just represents the location. It just represents the location you choose. Okay. So can you tell me, can we use all of this number to make any estimation? No. You understand? We cannot use all this number to estimate. You understand? Because, for example, I have 30%. I have 30%. They help me to answer the questionnaire, and I key in the Excel, and the data will be, the first person. The first question is 3. The second question is 4. The fourth question maybe 1. Okay. This is the first person. This is the answer from him. And here we also have the 30 items. You will also get 30 answer from the right? And the second will be maybe 4, and then 1, 5, blah, 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 blah. And the third will be maybe 1, 5, 4, da, 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 da. All this data is limited, right? In 5, all the data is only from 1 to 5. No other data, right? But the same question, the same item, he choose 3, he choose 4, he choose 1. The answer didn't concentrate, didn't locate it at some place. You understand? So if the data is nominal scale, you know, nominal scale for sexy, sure, male or female, male or female, we usually use first 1 to represent male and female is 2, right? This is nominal scale. We cannot calculate 1 by 2 to divide by all kind of this theory. Right? We cannot use this. This is nominal scale. All this data is nominal scale. We cannot estimate. We can use this data to do any mathematics. Understand? Okay. So this data is abnormal. Abnormal. Depends on your thinking. Oh, the same question he's thinking is 3. The same question he choose is 4. The same question he choose is 1. Not normal. Depends on your own opinion. So this is not normal. Okay? But if you don't know the data is coming from normal or abnormal, I will tell you how to use the SPSS to check out it's normal or not normal. I will show you a plot, QQ plot or TT plot. If your data is around here, this is normal data, normal. If your data is far away from the line, this is maybe abnormal. How to estimate that? What? Oh, if you know data is, you already have the confidence. You already know this data is coming from the normal. You don't need to check it. Just sometimes you don't know about it is coming from normal or not normal. You can use the software to check it out. If they come from a normal, what can we do by the statistic, right? Yeah, it's chapter 13. Chapter 13, okay. Continue. Please come here in my class continuously. Yeah, don't escape my class, okay? Okay, 5 condition, 5 formula, but from now on, only 3 conditions. You were confused. Why undergraduate university 5 conditions, but now master only 3 conditions? Actually, the 3 conditions include the other 2. Understand? Okay, but because our time only have 2 hours, so I want to claim, you know, remember tightly, mean claim. 3. Okay, from now on, if you want to compare, you want to test the two populations mean, only three methods. One is one sample t-test. Second is independent sample t-test. The third is dependent sample t-test. Okay. When we use the one sample t-test, when we will use the one sample t-test, when? Please remember my saying, okay? This saying is I invented, just like grandmother's saying. Grandmother's saying always very good, reasonable, useful. Teaching you sayings sometimes also very useful, okay? Please remember this saying. When you will use the one sample t-test, when the condition is like that, if you want to compare a set of data, want to compare a criteria, a value, a standard value. If you want to use a group, a collection of data, to compare with a value. For example, a pharmacy claims that their weight loss drug. I need it very much. Okay, weight loss drug can make user lose more than 3 kilos in short period of time. Or like me, I need the drug. Okay, if you are a pharmacy, you invent a weight loss drug, and if you drink my medicine, some day after you will lose weight, and I say you will lose weight more than 3 kilograms. This number is a criteria. Okay, if you want to challenge it, understand? If you want to challenge it, a standardized value. If you want to compare with the criteria number, you have to use one sample t-test, for example. And how about this? How do you design your research? Maybe you will go to the hospital, ask the doctor, right? And you give him your medicine, right? And distribute your medicine for the patient freely, right? Oh, you want to come here to lose weight? Okay, we have the new medicine. You can try it. Without any payment. Okay, and you will tell me about, for example, about after 3 months, how about your weight? So maybe you will select the first one. He will lose. This is lose the weight, maybe 3 kilograms. The second, he will lose 4.2. The third, maybe he will lose 5.8. Maybe the fourth. What it is? He didn't lose the weight, but also gain. Oh my God. Gain. You understand? Because it's after minus before, right? After minus before is 3. Oh, he lost the 3. But this is, after minus, he got it again. Okay, you got maybe 100 people there. This is the data, the weight they lose, right? You use this data to compare with the 3 kilogram. Using one data to compare with a criteria, sometimes you will use the data to compare something, some value, some standardizing, anything, theoretical value, anything. Just want to compare with the criteria. You have to use the one sample test, okay? Second, the red color paragraph is Dr. Liu's saying, okay? The two set of data were separate. First, it has to be separate. And the compare after same experiment was carried out at the same time. Two sets of data are separate, but when you want to compare after some experiment was carried out at the same time. No, again is dependent. Okay. For example, I have the two farm. Okay. Every farm I have the 10. I have 10 pineapple. Okay. I have 10 pineapple. This is A, this is B. I have 10. I have two farms, okay, A and B farm, and I also plant pineapple. A farm I use the traditional fertilizer. I use the fertilizer, right? And the second, I use the newer fertilizer. To be the fertilizer, right? And after some time, I use the fertilizer to plant the pineapple. That is the same experiment, same treatment, right? Every day, I give them fertilizer at the same time. So that is the same treatment, but just only use different fertilizer, okay? And after some time, after some period, I will test the sweetness. For example, I will test the sweetness A and B, which is better, right? That is the independent. Why? Because A farm is independent from B farm. And I use the fertilizer, it's also independent from this one. So this is an independent t-test. Okay? There, the sweetness of A and the sweetness of B, I want to compare with this. Which one is better? Usually I hope traditional I hope my neural fertilizer, I hope that will be larger, the screening, right? If I got this, oh my God, the neural invention is a successful, right? So sometimes, if you two sets of the data and separate, two sets of data are separate, and compare after the same treatment was carried out at the same time, you have to use using the independent sample test. Okay? Understand? Okay. The third, dependent sample. This is a separate, but if you only have only one farm, I'm sorry, I'm not so rich. I just have only one farm. But I want to test traditional fertilizer or the new fertilizer. After we planting the pineapple, which straightness will better? If you only have only one farm, how do you do? Comparing the average value before and after the event. When you compare comparison of the mean before and after the event, what kind of event? Use the fertilizer. Use the traditional. Before we use the traditional. Now we use the newer. Before we distribute the fertilizer is the event. Is the treatment. Before doing this treatment, the sweetness of the pineapple. After we use the new fertilizer, the sweetness of the pineapple. Compare with before and after. Before and after compare. The data come from something happened before, something happened after. That is dependent sample test. For example, just as I tell you, before English training course, right? The average score of our class is maybe 45, but we invite a teacher come here to teach our student English. After the English training, maybe 3 months, okay, the students, their score, right? Before and after. At this condition, all the sample is same people, right? Same place, same people, same thing. For example, our class have 40 students, so your sample size is 40. And before the English training, their English score, and after, the sample size is same. It's same student. Yeah. If you want to compare with something happened before and something after, you have used dependent sample t-test. Okay. And we take a 10 minutes rest. I will teach you how to use the SPSS today. Okay. Take a rest. As you see in this, this looks like the uh, worksheet of the Excel, right? Very similar to worksheet of the Excel. That means you can key in the data here, okay? And I transfer to English. If you install the SPSS and you find all the character traditional Chinese, if you want to transfer to English, okay? The second function towards edit, the last function, that is the option, okay? And you collect here, and you will find the second function, okay? You already installed, right? Here, you choose the second is about language, output and input. You choose the English, the language you as you like, okay? For example, I can choose I can change the output or input for English, output English, and then here, okay, click here, click, and they will transfer to English version, okay? All right? I suppose you already done that. And you will find there are two interfaces. Here is the output, the data, when you analyze your data, the output is they will print on this interface. And your input data you can key in here, right? Okay. And as you find, this is look like the worksheet of the Excel. As we knew, the first row of Excel usually be the field name, right? Field name. But SPSS, if you want to name the field, you can use here variable view. Okay, variable view. Okay, yeah, just like that. Okay. Okay. I give you an example. Remember, I ever have the sample for you, right? Chapter 2. Okay. Okay. Here is the Excel. I open the Excel data. Okay. This data is we will teach and use in our class today. Okay. You can use the Excel data, and you can also use the data from here. This one, ch2.sav. .sav is SPSS data file. Okay. So you can just like Microsoft software, you just open the data. Okay. Just please do with me. Okay. Do following me, and you go to the USB. Where is the USB? Okay, from here, and you open the folder under the chapter 2. Okay, and you will find a file. Its name is ch2, right? And open, please, and that you got it. Auto C, mullet, pasture, milk, okay? All right? Okay. And here, we change here, variable view. Just as I mentioned above, before you key in the data, you can name your field. For example, I will name field is O2, consumption. Mullet is a fish. fish name, molted fish. Molted fish, okay. I just use molted to represent the data, okay, as the field name. You know molted fish law? Molted fish law in Taiwan is very famous. We usually use the molted fish law as the present as a gift in during the Lunar Chinese New Year. But I think you don't, maybe you are foreigner like the molted fish law. You understand what is molted fish law? I think in Vietnam you also have a molted fish law. Yeah, Vietnam. I give you the picture. This is a raw egg, fish egg from a fish, what we call molted fish. Molted fish, understand? Taiwanese like this molted raw very much, and they roasted it and cut to pieces just like this. Yeah, you eat a lot of. When Lunar Chinese New Year is coming, usually Taiwanese use this to be a gift sent sent to each other. Okay. This is the molted. This is the molted fish. Okay. Okay. Yeah. Okay. Maybe this is coming concerned with the molted. Okay. So over here is the data field name. You know. Then I already key in the data here. And next time you will key in by yourself. Okay. This time I have everyone key in the data. Okay. And we want to make an example. What? Huh? Okay. I use this. Okay. Okay. First, I will give you an example about the one sample t-test. Okay. We will analyze about the one sample t-test. I will use the data used setting. A set of data compares with the criteria. Okay, remember this class I will teach about the concept of the statistic, and I will teach you how to use the SPSS to analyze your data. Then I will teach you how to make a conclusion of your result, how to write down the conclusion, write the interview of the result, how to explain. Okay. For example, we have the one example like this. A physical fitness researcher, actually a researcher, okay, conducted a random sampling survey on college students between age from 18 to 22. After 20 students had done the same exercise, their oxygen consumption was measured as the follow. A researcher collected data from how many students? From 20 students, right? From 20 students. So he got 20 students oxygen consumption data. What is oxygen consumption data? Sometimes we take exercise, we will feel very tired, right? So a lot of the oxygen, right? And after after exercise, our oxygen consumption is much more than normal condition, right? Okay, he want to make a research about if you after the exercise, your oxygen consumption will equal or not, then there will be significantly different from 2.5. This is a people usually, no matter what age of you, after exercise, your oxygen consumption at least 2.5. But he choose the student from age from 18 to 22, and then he measure their oxygen consumption after exercise. He want to make a research. The young man, the student oxygen consumption is significantly different from the people 2.5 or not, whether or not, right? Understand? So this is a collection of data compared with the criteria, right? One sample t-test. Okay, we used. So first we have to make a separate hypothesis. Null hypothesis. I already tell you. Null is equal, no change. So young man consumption is equal to the normal people. Their oxygen consumption is equal. H1 anti hypothesis is not equal. So here is two-way. Understand? Okay, and we will test our data. So please use your SPSS. For example, you already key in the data here. I already help you finish the key in the data here, 20 students. And how do we analyze the data? It's very easy. It's just click here, analyze, and compare means, and choose here, okay? Compare mean, one sample, independent. Pair sample is dependent, okay? One sample t-test, the independent t-test, and the dependent t-test. Here, I will mention you again. Please, take care. This software, t-test, he used the larger letter. Large letter. As you see here, right? But if you write in your paper or your thesis, please don't use large t-test. This is wrong. Because the programmer of this software, he don't know about statistics. A statistics scientist tell him, you just using my formula to transfer to the language of the computer language, okay? And okay, I t-test, but he the larger t-test is the Hotelian t-test. This is another t-test, okay? If you use the t-test, in your paper and you submit the paper to the journal, you will get only three vocabulary. If you use large related t-test in your paper and submit to the journal, the reviewer will give you only three words: poor, left at you. You know? I mean, you don't know about this. You don't know about this. You don't know about this. Even you don't know about this. I don't care about the quality of your paper. Understand? you don't know about the any sign of statistic, that means your paper, the quality of your paper is poor. So it will give you poor English ability, and reject you very soon. Maybe today you submit, tomorrow morning he will give you poor English ability. No, without any explanation. So everyone, it's a small thing, okay? And I click here, and we got this. And this data is what we want to analyze. So we put this data, we click the arrow, send the data here. And this is the test value. The test value will be how much? 2.5, right? He will compare with this criteria. So here we click 2.5. And the opinion, should we change or not? 95 competence interval percentage is 95% is usually, so we don't need to change anywhere, okay? So we just put this, and we got the data, and the answer is here. It's very easy, right? And you have to use this. You got two tables. One table is the one for a statistic, their description. Sample size is 20, and the mean is 2.550. Standard deviation is 0.789, right? Okay, this is a description of all your data. Here is more important. T value is 0.839, right? And the significant, the two-way is 0.412. It's larger than alpha, 0.05, right? So, which one? This conclusion is I want you to remember what you learn right for your master C in the future. You have to make a conclusion. According to the result, T is equal to 0.839, and the P value is 0.412, larger than 0.05, right? Long, S is long significantly, long. N-O-N, okay? Non-significant. So you find, if find some paper, write NS. NS is non-significantly different. There is no significantly different between our data and the value. So the neural hypothesis is holds. Holds being we accept the neural hypothesis. Accept the neural hypothesis means that what? Even you are a young man, your oxygen consumption is equal to the common people. Understand? So that is the oxygen consumption of college student after doing the same exercise is not significantly different from 2.5. Okay? Everyone has to learn how to make this conclusion. Okay? But yeah, 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 yeah. But remember, what is statistics? Statistics is the concept of the statistic is we use a little sample to interfere the population. We use the sample character to interfere the character. That means here accepted. That means all the colleges, their oxygen consumption is equal, no different. You understand? If the result is here, that means all the college students, their oxygen consumption will be significantly different than the 2.5. Understand? 2.5 is normal people. Yeah, without no matter what age of you, normal people. So we use the samples character to interfere the population. Understand? We use their character to interfere there. Understand? Okay, I'll give you the second exam, okay? A fisherman wants to know whether the weight of mullet he raised is significantly better than the average as claimed by the manufacturer who sells his feed. Okay, if you are doing the agriculture, some people will come to, especially the salesman, right? He will come to your farm. He will promote his some product of their company, right? Usually they promote their feed, right? Okay. If you want to test their the bet of the product is good or not, right? You can make a test. But he said the fisherman he randomly fished 60 mullet. 60 mullet. The mullet I already showed you, right? And the measure of the weight is shown in the following table. Okay, in the table below. The average weight of the mullet in the farm during the same period is 3.8. Mean you use all the feed from the from any brain, then we make the knowledge grows up the average weight up to 3.8. But if you using the new product, right, the weight of the new product, the knowledge who the farmer used the new feed, we are larger or not, we are better or not, significantly better or not than this. The hypothesis you can write down like this. I hope there, you also use it. I hope the knowledge fish you use the newer product, the mean weight we are larger than the common fish, right? Here is some fish. Okay, we use the traditional feed, bed. We use the traditional to feed the fish, and then they will grow up. They will the weight, the average weight after, for example, after 3 months, they will again the weight about 3.8 kilogram, right? But if you someday, if you using my newer feeder, I say I announce if you use my newer feed, their weight will larger than this, right? So this is one sample compared with the criteria, right? So one sample t-test. Okay, just like this. Please do your t-test and analyze compared to one sample t-test. Okay, now change oxygen to consumption, move back, and move it move forward. Okay, and the test value will be 3.8, right? Okay, and you got this. Okay, and we back here. Okay. You got t value is 3.795, right? And the two-tail significant is 0.001. Okay, at the statistic, we have the standardization. If alpha is we setting of this is criteria value, critical value, okay? If alpha is we set 0.05, if your p value is lower than alpha, we give a 1 star. If your p value is lower than 0.01, give 2 stars. Give 0.001, give 3 stars. Okay. Here, its p value is 0.001. Oh my God! But it's equal to this. So only we get the 2 stars. Okay. Okay. If you got this, we say significantly different from the paper. Only one. If larger, we say non-significant. If smaller than 0.05, we say significantly from 2 is very significantly from 3. How to say that? Very, very, just very, very, nothing. Very, very significant. Okay. Yeah. So Dr. Liu is a 3 star. Handsome. Okay. Very, very handsome. Okay. I'm sorry. 5 star. Okay. Okay. You are very cute. I like you. Okay. 3. Yeah. 5 star. Yeah. Yeah. Maybe we can have a bottle of wine after the class. Yeah. Just like a VIP. What is VIP? Very important person. VIP is a very important person. Okay. Oh, you are a very, very important person. What is it? How you say that? WIP. Why is WIP? Because it's very, 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 very. So we combine it very, very together. Very WIP. So sometimes we call that, oh, you are my WIP. That you are very, very important. Understand? Just cheating, okay? VIP is a very important person. Okay? So because the significantly vary with the 0.0 is very, very significantly. So we make a conclusion that according to the result, T is equal to 3.795, 2 star. P value is smaller than 0.05. Actually, here you should have to say, right, 0.01. So that's one anti-hypothesis. Holds, okay? Holds means accept. That is the weight of mullet based by the fisherman is, oh, very, very sorry. Here you should have added the 2 words. Very, very, okay? Sorry. Very, very significantly different from the average of 3.8. Understand? Yeah. Okay. So I will give you. Okay. Continue. All right. Independent sample test. Okay. Independent sample t-test. Okay. Yeah. There are 12 dairy cows were fed with withered pasture. Withered pasture does not mean the grass is already dried. You understand? Yeah. The cow we usually fed the grass, right? But if it was withered, that means we already dried the water out. Okay. And the other 13 cows was fed with dehydrated pasture. Dehydrated pasture is what I mean. That we use some machine to consume out, to extract out the water, okay? That means we use two different pasture, 2 different feed to feed the cows. And then we will compare the function of these 2 kinds of grasses. Okay? What kind of function? We will compare with their daily average milk production. We will compare the milk consumption. Okay? That means if you fed with the pasture, their milk production will be 44, 44, and the other, if you feed with a dehydrated pasture, their milk production will be this. Okay, which one is better? This is a two kind of data separated and doing the same experiment, doing the same treatment. After the treatment, comparing the meaning. This is independent because they independent feed. They are fed with a different pasture independently. So our hypothesis will be mu1. First, milk production, milk production is equal to the second. The anti-hypothesis is not equal. Okay, and we use our SPSS. When we want to make an independent t-test, remember please, you have to use two fields. One field is the group, because you have the two groups, right? One is fed with the first pasture. The second is you fed with the second pasture. So the first field, you have to type the 101 to define your data. This data is belong to the first. The other is belong to the second. But here, you have to although you type 1 and the type 2, right? But you have to define the pasture with the 1 or 2 value. You have to define the 1 or 2 value. Because why we have to define the 1 value here, the labels here? Why we have to define the value label here? Because someday we will forget 1 is what kind of the pasture. So if you key in the data, if you do the independent t-test, you must define the value level. One is with the pasture, the second is dehydrated, and then the output they will print the with the pasture, dehydrated pasture. If you didn't define label, you will see 1 and 2. Someday after, you will forget it. What is what? The second is what? You understand? Okay. So we analyze comparison mean independent sample t-test. Okay. Then milk production or test variable. Pasture is group value, right? And we also, because we use the number 1 to be the first group, number 2 to be the second group. So we define our group. Here has 2 t value. One t value is 0.868. The other t is 0.864. Which t we have to use? We can use independent t-test. They were the SPS as they will give you two answers. One is this, one the other is this. But what value you have to use? Okay, we back to here. T-test. When the sigma, the variance is equal, we use this. When the variance is not equal, we use this test. 2t, the formula of the t is quite different, right? So, but the SPSS software, he don't know your data, the variance is equal or not equal, right? But how do you know your data, the variance of your data is equal or not? You have to judge from here. F value, because F value is, the formula of F value is equal to samples variance divided the sample variance. If they are equal, that means the p value is larger than 0.05. That means the variance of two population is equal. If the p value is smaller than 0.5, that means a significantly different. Significantly different, that means their variance is not equal. Okay? Here, F value is 0.176. Significantly is 0.678. The significantly 0.678 is larger than 0.05, right? So that means this. That means they come from the same population. Okay, so the variance is equal. So we choose this equal variance assumed. We use this 0.860. Okay, if this is not equal, we use this. We use this t. Understand? Okay. So what? Yeah. We just use the t value, yeah. And what do you want to add? Yeah. Because the variance is equal. You understand? Yeah. Because it gives you two answer, right? But which t you have to use? We judge from here. Yeah. F test. Okay, give me. If you want to make a t-test t-test actually is testing the value, the mean, right? But before we make the t-test, actually we should make an after test. After test, why we make an after test? We have to make sure the variable is equal or not. Is it or this? Understand? Here, that test, we got the H0. We use the T like this. We use this formula. But if we got this, we use another formula. Different condition, use different T formula, and then we got the different T value. Understand? And the next week, I will explain why, before we estimate this, why we don't know about their, we want to compare the value mean of the population. We want to compare this. We don't know about it, but why we know this first? Yeah, next week I will tell you. Because we only have 2 hours, right? Sorry. But here, we made the last conclusion. Okay, according to the result, T is equal to 0 to 8, 869, okay? So H0 is null hypothesis, it holds. That is, the yield of the mu raised with the pasture is non-significantly different, not significantly different than from that of the dehydrated test. That means you use two kind of food, the milk production is equal. So in the future, if you want to feed the cows, and the milk production will be the same, no matter what kind of the grass you use. You understand? Okay, because the time flies so quick. Today we had to end our class. Okay. Any question? Yeah. 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 This one. One is 0 point. The other is different formula. The result not always the same. Okay. In this condition, we have used this. Okay. Yeah. 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 Here, the F P has P value. The P value is used to judge this. What? Okay, because the P value for this is larger than 0.05. So This hold means 2t, we have to choose this equal variance. Yeah, because this is equal, so we choose this. But if significant, we choose this. Okay, but we choose this. Here, the data, we estimate the t is 0.869, and the p of the t test, okay, the p is also larger, very large, because the p is 0.395 of the t test. So it is also very large, larger than 0.05. So we accept this. So 2p, this p is decide this. This p is decide this. Okay? So p is for different use. Any question? Okay, thank you. See you next week. I will explain what it is. Can anyone hear me? Before we know this, why we know this?